Assalamualaikum and hello everyone. Welcome to the video for Chapter 4, Introduction to Organic Chemistry for 4.6 Basic Reactions in Organic Compound. In this video, what we're going to learn is to describe electrophile and nucleophile and predict the type of organic reaction, either it's substitution, addition or elimination reaction. So on your notes, it will be on page 18. Again, in 4.6, the name of subtopic itself is basic reaction in organic compound. Okay, later on when we learn further about the functional group, later on when we learn about the reaction, and then you will see these terms is being used lah, which is electrophile and nucleophile. So what is meant by electrophile and nucleophile? First, we're going to look at the electrophile. Okay, what is an electrophile? Electrophile is a species that love electrons. So that's why the name is electrophile. So electro means the electron itself. Phile means love. So it means that it loves electron. Okay, so when it loves electron, it means that it is a poor electron species. Again, usually we will love what we don't have lah kan? So in this case, it is electron poor species, so that's why it loves electron. Can either be neutral or positively charged. For example, what is the positively charged? It is a cation such as H+, H3O+, NO2+, or even our carbocation, which means our carbon with a positively charged on it. The other characteristic for electrophile is electron pair acceptor, or we could call it as Lewis acid. Okay, so why it can accept electron? Because for example, I'm just going to draw for AlCl3. So when we draw the Lewis structure for AlCl3, we can see that Al haven't achieved octet yet. Again, Al is actually an example of incomplete octet. So when it is an incomplete octet, it means that it can accept electron to achieve octet itself. So that's why AlCl3, FeCl3 or BF3 is an example for electron pair acceptor. Again, why? Because it's actually an electron poor species, haven't achieved octet yet. Okay, and the last characteristic of electrophile is that it has a low electron density carbon atom. So what does it mean here? It mean that the electron on carbon is low. Why? Because it means that we have positively charged carbon atom or carbocation. For example, if we have here C double bond O, again, carbon is actually in group 14, while oxygen on group 16. So even though here we know that there's 4 electrons, but then for this case, actually, the electron has their favorite, which is more electronegative atom. Again, for the case of electronegativity, it is Senov, or we can show it from group 1 until group 17. This one, order of higher electronegativity. Okay, so what is meant by that is that even though it being shared equally, but then the electron actually prefer to go to the oxygen or the group 16. The same goes here. Again, carbon is group 14 and halogen is group 17. Okay, so again, carbon is actually has 4 valence electron. Halogen have 7 valence electron. So actually, electron is more attracted to the halogen itself. Again, because why? The halogen needs only 1 more electron to achieve octet. Okay, so the same goes for the hydroxyl as the carbonyl. Why? Because carbon we have group 14 and oxygen on group 16. So even though we have 2 electron here, the electron actually prefer on the case of oxygen itself. Okay, so that's why we have delta negative. Means that even though it's being shared equally, electron actually prefer towards oxygen. Dia ada favorite dia sendiri. Okay, so that is the definition of electrophile. Now we're going to learn about the definition of nucleophile. So nucleophile is the direct opposite of electrophile lah. Okay, so nucleophile is actually a species that love nucleus. So that's why they're nucleophile. Nucleo tu stands for nucleus. Phile ni means that likes lah. Loves nucleophile. So why does it love nucleus ataupun nucleus ni positively charged lah. Okay, again we always love what we don't have kan. So it means that for the case of nucleophile is actually electron rich species. Banyak elektron dekat situ. When we have lots of electron, it means that more of negative charge lah. Hence dia suka yang positive, opposite attract. Okay, so it can either be neutral or negatively charged. Again, negatively charged means that we have lots of electron rich. So that is the definition of nucleophile. Okay, so what is the example of negatively charged for our organic compound? Okay, so the example for it is anion such as OH minus, OR, R again is any carbon, Cl minus any of our halogen, and Cn minus is cyanide. Okay, so the other definition of nucleophile is electron pair donor. So electron pair donor means that it is a Lewis base, okay, where it can donate electron means that we have the presence of lone pair on the atom itself. For example, for NH3, actually the shape or the Lewis structure will be like this, NH3. Okay, with the lone pair. So again, due to the presence of lone pair, hence we call it as electron-rich species. Okay, the same goes for H2O. So for H2O, again, the shape is like this. So it's the same lah. Where the presence of lone pair means that it is an electron-rich species. So it is a nucleophile. Okay, and the last definition of nucleophile is where we have high electron density carbon atom. Okay, means electron-rich areas such as carbanion, double bond, and benzene ring. Again, this case, okay, all the bond is between carbon and carbon. But then why would you call it as electron-rich? Because here, actually between double bond between the carbon here, we have actually 4 electron. So it means that it is an electron-rich. For alkyne, we actually, again, for each bond means that we have 2 electron. So here we have 6. The same goes for benzene. Between this carbon and carbon, we have 4 electron. Between this carbon and this carbon, we also have 4 electron. And between this carbon and this carbon, also we have 4 electron. Okay, so that is the last definition of nucleophile. Next, we're going to learn is about type of organic reaction. Next, what we're going to learn is the type of organic reaction. So please correct your notes. It's actually type of organic reaction. So there are 3 types of reaction that we're going to learn. The first one is addition. So what is actually addition reaction? It is a reaction in which atom or group of atom is added. Okay, so it is added to the adjacent atoms of multiple bonds. So what is the example of multiple bond? That is double bond or triple bond. Okay, so this case only one product will form. Okay, so there are 2 types of addition reaction. One is electrophilic, second is nucleophilic addition. So for your syllabus, it is not compulsory for you to know that it is electrophilic or nucleophilic addition. But then I'm just gonna introduce to you about electrophilic and nucleophilic addition, because later on we're going to see this reaction during the next chapter. Okay, so first we're going to look at is for the electrophilic addition. For electrophilic addition is a typical reaction of unsaturated compound such as alkene and alkyne. So what is alkene? Alkene is where we have double bond between 2 carbon, while alkyne is where we have triple bond between 2 carbon. Again, this reaction, addition reaction, we're going to add to the double bond or the triple bond. So what happens when we're adding the atom, the double or triple bond will be removed lah. We only have single bond. So how do we know it? So let us draw, this is in terms of condensed. Let us draw the structure of the reactant here and the product in terms of expanded. So it is clearer for us to see that is addition reaction. Okay, first I'm going to start with this alkene first. On the reactant side here, we have 3 carbon, and between carbon number 2 and 3, we have double bond. Okay, and then make sure that for each carbon, only have 4 bond. Okay, so this is the reactant or the before. Okay, how about the after? Okay, so the after we're going to draw the product only. Okay, so let us draw again. We have 1, 2, 3 carbon. And then for this case, we don't have any double bond shown. So it means that between all the atoms itself or between all the carbon, only have single bond. And then make sure that for each carbon have 4 covalent bond. How about the arrangement? Let us follow the first carbon. We have 3 hydrogen. The second carbon here have 1 hydrogen and 1 bromine. So if you want to put bromine here, you can put the hydrogen here or vice versa. You can also write down this one H, this one is Br. So the position is fine, whether it's up or down, but make sure it must be on the carbon number 2. And carbon number 3 here is attached to 2 hydrogen and 1 bromine. Okay, once you draw the expanded version, you can see that there's an addition where previously we have 3 carbon. This one also 3 carbon. This one we have 1, 2, 3, 4, 5, 6. Okay, we have 6 hydrogen. The same goes here. 1, 2, 3, 4, 5, 6. Okay, but then when we look here, the difference is that from the double bond, it will become single bond. Okay, and then we're adding 2 extra atoms, which is this bromine and this bromine. Hence, we know this is an addition reaction. For the electrophilic addition, it's not compulsory. This is an introduction for you to learn. During later on, we're going to see this during chapter 6. Okay, but then again, for the case of addition, the reactant must be double bond. Okay, this case alkene or alkyne for electrophilic addition. So that is for A. For B, it is nucleophilic addition. For nucleophilic addition, is a typical reaction of carbonyl compound. So what is meant by carbonyl compound? It means that on the carbon itself is attached to oxygen. And it must be C double bond O. Okay, why C double bond O? Again, oxygen must have 2 covalent bond. So here lah, 2 covalent bond. Again, the reaction is addition. Addition must occur at the double bond or triple bond. Where previously the double bond is between carbon and carbon, or triple bond between carbon and carbon. This one for the nucleophilic addition is carbon double bond O. So what happened here? Because here it has shown the expanded version for the carbon in the middle here. Okay, we can see that we are adding the atom of H here as well as Cn. Okay, why can it form this one? It's actually because double bond O here, instead of double bond, it will become single bond, just like this one. Okay, so again, for the case of addition, okay, the reaction is when the double or triple bond will become single bond. Okay, so that is for the case of addition reaction. The second type of reaction is elimination. So what is an elimination reaction? It's actually the opposite of the addition lah. So elimination reaction is in which an atom or group of atoms are removed, or in this case are eliminated. Okay, from the carbon atom of a molecule to produce a double bond or triple bond. Okay, so when we look based on this example, it has drawn the compound in terms of expanded. We can see here that we have alcohol, and then it remove H and OH. Okay, once it remove H and OH, okay, what would happen is that we're going to remove it. It will become a product plus H2O. But then when we remove this, each carbon here only have 3 bonds. So that's why it has here a double bond. Okay, to make sure that for each carbon have 4 covalent bond. So let us count. This carbon have 1, 2, 3, 4. Okay, the same goes for this carbon. We have 1, 2, 3, 4. Okay, so this is elimination. So it is the opposite. So elimination is from the single bond to become double bond. Where addition just now is actually from double to single bond. Okay. Next example that we're going to look at. Okay, here we have the haloalkane. Okay, and then in the ghost reaction, it become a double bond. So in this case, what is being removed? Okay, carbon is still here. And then we have 4 hydrogen. Originally, we have 1, 2, 3, 4, 5. Okay, so one of the hydrogen is being removed, and then we remove as well the Br. So in this case, we are removing HBr here. So that is for elimination reaction. The third and the last type of reaction that we're going to learn is substitution. So what is substitution? Substitution is actually a pergantian. Okay, kita gantikan dia. Okay, so substitution reaction is in which an atom or group of atom in a molecule is being substituted or being replaced. So we're just going to add both substituted or replaced. Okay, so there are three types of substitution. Again, you don't have to memorize the free radical, the electrophile aromatic, or the nucleophilic. This one, I'm just going to show it to you here because it's actually later on we're going to learn more about this type of substitution itself. Okay, but then let us look for the first case, free radical substitution. Okay, for free radical substitution, it is a substitution reaction, okay, which involve, since the name here we have free radical, so here it means that for the reaction, it involves free radical as intermediate species. So how do we know it is free radical substitution? When there's the presence of UV, or sometimes you use HV. Okay, so here is the UV here. Okay, so how do we know it is a substitution? Okay, so let us draw the expanded structure for CH3 here. So this is the before. Okay, how about the after? The after, I'm only going to draw this one. Okay, again, because here we have two carbon. Okay, first carbon is attached to 3 hydrogen. Okay, and the second carbon is attaching to 2 hydrogen and 1 Cl. For this type of reaction, this is not addition reaction. Again, addition must be from double bond or triple bond to become single bond. This one, all of the structure is in single bond to become single bond. Okay, it cannot be elimination because there is no removing any of the atom. So what actually is the difference? The difference is actually is this one. From the hydrogen, it becomes Cl. So we call it as substitution, or specifically free radical substitution. How do we know it's free radical? Because if we have UV. Okay, for B, electrophilic aromatic substitution. Okay, this reaction is typical reaction of aromatic compound. So what is example of aromatic compound? It means that the reaction is the one with the benzene ring. Okay, so this is another drawing of benzene ring. Usually we draw it using this one, right? The hexagon with double bond, single bond, double bond. Okay, so let us draw this one in terms of expanded. Okay, again, it follows the shape of hexagon. Okay, 1, 2, 3, 4, 5, 6. And then we're going to connect each of the carbon with the single bond. But this is not the benzene ring yet. Benzene ring must have alternating double bond, single bond, double bond, single bond. So we're just going to start anywhere that you want. Okay. And then, so when we look based on each of the carbon here, each of the carbon only have 3 bonds. So what does it mean? Okay, it means that the carbon have 1 more covalent bond with hydrogen. Okay. Okay, so this is the for the reactant. Okay, so how about the product? Okay, so it's still the same where we have carbon here. But then, here, for the case of the reactant here, we do not see any atoms attaching to the carbon. So it means that there's the presence of hydrogen. But for this case, we have bromine attached to the benzene ring. It means that any one of the carbon is attaching to one bromine. So I'm just going to draw it here. So when this one is attaching to bromine, the other must be attaching to hydrogen. So again, this case, this reaction does not undergo addition reaction because double bond is not changing to single bond. The double bond is still there. And it cannot be elimination because we do not eliminate any atom. So what actually is the difference? The difference is that the hydrogen is being replaced with the bromine. Hence, this is a type of substitution reaction. But specifically, it is electrophilic aromatic substitution because it contains the benzene ring. The last type of substitution is nucleophilic substitution. For nucleophilic substitution, is a typical reaction for alcohol and haloalkane. So for the case of alcohol, it means that the carbon containing OH. For the haloalkane, the carbon can be attached to fluorine, carbon with bromine, carbon with Cl, or carbon with iodine. Any halogen. Halo means that halogen. Halogen is actually the atom in group 17. Okay, attaching to alkane. So carbon attaching to the halogen group itself. Okay, so how do we know it's a substitution? So again, let us draw this structure in terms of expanded. Here we have first carbon attaching to 3 hydrogen, second carbon attaching 2 hydrogen and 1 bromine. Okay, and then how about the product? Okay, this product still have 2 carbon, but this case, first carbon attached to 3 hydrogen. Okay, the second carbon is attaching 2 hydrogen and OH. So what is the reaction happening here? It's actually a substitution again, where we substitute the bromine with the OH. Okay, so again in your syllabus, you just have to know that the reaction is substitution. Okay, later on we're going to learn during the next chapter, okay, where we have free radical substitution, electrophilic aromatic substitution, or nucleophilic substitution. So that is all the type of reaction for 4.6. Okay, now what we're going to do is actually we're going to discuss the examples on page 19 and page 20. We're not going to discuss all, we're only going to discuss several of the examples here. Okay, so based on the example here, it mentioned to identify the types of reaction shown by the following equation. So if the equation given is actually in terms of condensed or skeletal, it is actually easier for us to draw it in terms of expanded, just like this one. So that will be easier for us to see what is the type of reaction present. Okay, so let us look for example number 1. So example 1 here have 1, 2, 3, 4 carbon, and there is a double bond between carbon number 3 and 4. Okay, make sure that each carbon only have 4 covalent bond which is bonded to the hydrogen. Okay, so this is the expanded structure for the reactant itself. Okay, now we're going to look at for the product. Okay, so if you're not sure, let us label how many carbon is present. 1, 2, 3, 4. So 4 carbon. Okay, and then it have written down here for each carbon. Okay, what is the atom that is attached to it? Carbon number 1 have 3 hydrogen. Carbon number 2 have 2 hydrogen. Carbon number 3 have HBr. The same goes for the carbon number 4, but H2Br. So let us draw. Okay, so from here, let us look for the before and after. So what is actually the difference? Okay, the difference is that the first one, we have double bond. But then, after the reaction, there is no double bond present. And then we can see that there's actually an extra. We have extra bromine here and bromine here. So again, there are only 3 types of reaction. Either addition, where we're adding, elimination, where we remove the atom, or substitution, where we replace the atom itself. Okay, substitute. Okay, so what is the type of reaction? Since we're adding atom to atom here, so this one is addition reaction. So again, you don't have to be specific. Is it electrophilic or nucleophilic? You just have to mention between those 3. Okay, so that's for example 1. Now let's look for example 2. Example 2, again, we have 1, 2, 3 carbon. Okay, first carbon have 3 hydrogen. Carbon number 2 is attached to H and OH. For this one, make sure the carbon is attaching to the O, not H is attaching to here and O here. or OH. The carbon must be attaching to O. Okay, and then the last carbon is attaching to 3 hydrogen. So this is for the reactant or the before. Okay, how about the after? So let us draw again. We have 3 carbon, 1, 2, 3, and there's double bond between carbon number 2 and 3. Okay, and then we follow for each carbon have how many hydrogen present. So this is the product or the after. Okay, so what is the difference? Okay, the difference is that for the product, suddenly there's a double bond. And then actually, okay, here we have 3 carbon. The hydrogen here we have 1, 2, 3, 4, 5, 6, 7, 8. Here we have 1, 2, 3, 4, 5, 6. So the hydrogen, okay, is decreasing. Okay, and then the oxygen is not there anymore. Okay, so what does it mean is that actually for this reaction, we are removing the OH and H. Okay, so it cannot be addition because there is none of that. There is none of the atom is being added, but actually it's being removed. So the reaction is elimination. So we're just gonna write down this is elimination reaction. Okay, so that is for example number 2. Example 3 and 4, you may try yourself. So now let's look for example number 5. Okay, so for example number 5, here actually we have our benzene ring. So for the benzene ring means that actually we have 6 carbon attached to it. Okay, so let's draw it. And then make sure that each carbon containing 4 covalent bond and it is attached to hydrogen. So that is for the reactant or the before. So how about the product or the after? Again, it has 6 carbon on a hexagon. But then for this case, the carbon at the top here is attaching to another CH3. It's not attaching to hydrogen. It is attaching to CH3. So here I'm just going to write down attaching to CH3. So how about the other carbon? The other carbon will be attaching to hydrogen. Okay, so what is the type of the reaction here? The reaction cannot be addition. Why? Because for the addition, the double bond or the triple bond must be a single bond afterwards. But this one, the double bond is still there. Okay, so there is not elimination as well because nothing is being removed. So actually what happened or what is the difference is that the hydrogen at the top from the reactant is changing to CH3. Okay, so what is the type of the reaction? The type of the reaction is substitution, penggantian ataupun it is being replaced. The hydrogen here is being replaced with CH3. Okay, so that is for example 5. The last example that we're going to discuss in this video is example 6. Okay, here we have C double bond O. So I'm just going to draw the same as the condensed structure here. But the C double bond O here is attaching to 2CH3. Again, this carbon can contain 4 covalent bonds. So right now, it contains only 2. So when it has 4 covalent bond, it is attaching to another CH3 here and another attaching to another CH3 here. So this is the reactant. Okay, so how about the product here? Okay, so here it mentioned about CH3 2 times. It can't be CH3, CH3. It cannot be this way lah. Because later on, how do this carbon attach to another carbon? Or the hydrogen attaching to another carbon? So what happened here is that this carbon in the middle, still attaching to 2CH3, the same as this one. But right now, this carbon is attaching to OH. And then this carbon only have 3 bonds. So right now, what is another bond? Okay, what is the other atom that is attaching to this carbon? It's actually CN is attaching to this carbon as well. So here it will become CN. Okay. So from the before and the after, or from the reactant to the product, okay, so what is the difference? First is that from the double bond, it will become 2 single bond. And actually, the double bond O become the OH. Besides that, there's an addition of CN, where previously we do not have any CN here. So this is actually the addition. So again, so what is the type of reaction. So this reaction, okay, for the addition or substitution, you don't have to be specific to be nucleophilic or electrophilic. Okay, we just only mention this one is addition reaction. Okay, so for this type of question, again, how to know the type of reaction? First, what we're going to do is actually from the reactant or the before and the after, draw the expanded form so it is clearer to you what is the type of reaction. So that is all for this video.